Moin! In this video I explain how I create a real metal layer on a 3D print. And this is especially useful for making convincing props or cosplays, and I will now go through each step and address the individual challenges. This C3PO is my best result so far, but it also took a really long time. Let's get started. My starting point for electroplating is almost always a 3D print. With my X1 carbon and simple PLA, I can also create larger items like the head pieces here. I always try to achieve the smoothest and cleanest prints possible, as this greatly affects the final quality of my creations. This print turned out wonderfully. For the smaller, more detailed parts of this project, I use my resin printer as usual. Elegoo provided me with a Saturn 4 Ultra for this. I've never had so few problems with resin printing. Although these prints are generally more cumbersome to produce compared to FDM, they require significantly less post-processing to achieve shiny metal coatings. A hot air gun works great for removing supports with minimal residue. Yeah, but let's put these aside for now because we need to focus on the FDM print. We need to seal the print as good as possible because if the electrolyte seeps into the print, it's a bad situation, definitely something we don't want. It can later seep out, crystallize, and it's just a mess. Typical areas to watch out for are overhangs and edges. To patch these up, I use resin mixed with baby powder. I brush it on generously and cure it with a UV light. It works really quickly and reliably. I think I might have used too much baby powder. Before we get into sanding, let's talk about PPE. Hendrik tends to forget about it, so let's not skip it. Hop hop, safety first. Much better. Now I'm sanding everything as smooth as possible. For distortion-free mirror-like coatings, everything needs to be as even as possible. I'm not afraid to use coarse tools to tackle the layers. Everything that's smooth now will look great later. And I really try to collect the microplastics produced in the process. Once the print is fairly smooth, I apply several layers of filler spray. After thorough drying, I can sand it down with finer grits, and in the end I have a really even print. Phew! Now we are finally getting to something exciting, the electroplating process. You need a few things for this: copper wire, conductive paint, gloves, electrolytes, an airbrush, fossil trilobites. Wait, not those. But let's start from the beginning. First, I make the print electrically conductive. For example, I use conductive copper paint made from copper powder and acetone, or graphite paint made from graphite powder, acetone and superglue. Once sprayed on, it's permanent. My old spray booth was worn out, so I bought a new one. Yes! My old airbrush had done more than enough, so I retired it and got a new cheap 0.5mm one, because we will airbrush the conductive paint. This provides a very thin and even base coating. To better grip the large parts, I printed some holders and fixed them with hot glue. I try to work evenly and spray on a thick, smooth layer. I use around 2 bar for this. Let it dry thoroughly and, if necessary, gently smooth it out with a brush. Gently. On this layer of copper paint, I now deposit a very thick layer of copper. This is done using an acidic electrolyte solution in which the 3D print is submerged. I use large containers from the hardware store for this. They allow the piece to rotate freely. However, the volume scales quadratically, so I need 10 of these 5-liter containers. Yes, 10. And now I place copper plates called anodes on both sides of the tank. A voltage is applied between these anodes and the print, which rotates in the center. This causes copper ions to travel through the solution and deposit onto the 3D print. The anodes dissolve into the solution, thus generating it so I can use it over and over again. Now about the current. How much do I need? For this, I use software like Blender to calculate the actual surface area in square decimeters. This gives me an approximate target current for the process. So just coating one side that requires 9 amps, which means my 5 amps max power supply is already out of the question. I need more power, and here's a great device that can handle up to 30 amps. Now I just need to wrap a wire around the 3D print so the current can flow through it and connect the negative terminal of the power supply. The highly sensitive coating can easily get scratched in the process, so be careful. Done! I hang the whole setup on my rotary jig and let it rotate nicely in the tank. This ensures a more even coating. I set the power supply to constant current and then I let the electrochemistry work its magic for 4 hours. If everything went well, we now have a 3D print coated with about 0.2 mm of copper. Now begins the long process of polishing. To achieve a mirror finish, I go through various sanding and polishing compounds. For more complex parts, like the rear headpiece here, small sanding machines can be very helpful. In any case, the whole piece now needs to be polished to a high shine. The shine in electroplating always comes from the surface underneath. Next, we use additional electrolytes like palladium and then gold to gild the print. Palladium acts as a barrier layer between the gold and copper. For this, I use the galvanic pen, which is essentially an anode holder, in this case graphite, that directly applies the electrolyte to the metal. It's like a bath, but smaller and quite different in operation. It works well, although the layers aren't as thick as those deposited in the bath. Here you can see how thick the layer can get in the bath. So turn on the power, set the 3D print as the cathode, dip the non-woven pad into the electrolyte and apply it in a circular motion. First with palladium, then with gold. Did I just say non-woven? Well, anyway, the hardest part is now done. We still have several smaller parts left, and you know what? I actually prefer working on them. The process is essentially the same, but everything is much easier to handle. For anyone attempting this, I would definitely recommend starting with smaller objects, as they are much easier to manage. Honestly, if you're just beginning, there are a few basic rules I've learned. For example, start small and work cleanly. For instance, I haven't mentioned yet that I always degrease everything before each electroplating process. You absolutely can't skip this step. Also, rinse everything constantly with distilled water. Avoid using potentially hazardous electrolytes like nickel and stick to copper first. Don't get discouraged. I don't mention how many failures I've had. I often read that it looks too easy, and that's partially true. But in the end, it's all about practice and experience, right? Before we gold plate everything completely in the bath, yes, we're going to build the eyes. These ones. The whole project has taken so long that Elegoo released the Mars 5 in the meantime. And now I'm pouring in the oldest transparent resin I could find, expired in 2018. Hopefully the eyes will turn out a nice yellowish color, as can happen with transparent resins. After several successful tests with very long curing times, the lenses ultimately turned out extremely clear, not a trace of yellow. So I used my warm white LEDs, bent and soldered them nicely together, so they can be placed behind the eyes. It works great and looks really convincing. Now, bath electroplating with gold and nickel. What can I say? Power, electrolyte, distilled water. I'm using nickel as a barrier layer here, though palladium works too. It's actually better, so use that if you can. I've set the power supply to a constant voltage, just like with the pen plating. Nickel plating takes only about a minute. The gold electrolyte must never come into contact with acid, which is why I rinse everything and use disposed of and recycled them separately. The gold plating also happens very quickly, however, the gold bath doesn't regenerate, unfortunately, right? Seriously, gold looks amazing. Now let's assemble the eyes. For each eye I connect 3 LEDs in series and hook them up to a 9-volt battery. Then I secure everything and insert it into the front part of the 3D print. I glue the wheels and bolts to the side, but I made the antenna on the head attachable with a screw. Now we just need to attach this collar and it's done. Oh, and you can actually wear it and see through the eyes. It's a very interesting feeling, I must say. Another question, is it worth it? It takes a very long time to produce something like this. Many hours. In the end, you have to ask yourself if it's worth it. It's definitely very close to the real deal, and it looks amazing on the shelf. See you soon!